In the previous section, we introduced the formal definition of inverse functions. And we also saw that inverse functions are unique when they are defined. Let's go ahead and find out how to find the inverse functions given that our functions are in fact one-to-one. The method that we're going to be using to find inverse functions isn't going to work for all functions, but in most cases it will. To do this, we're going to follow the next few steps. Step 1, solve the equation f of x is equal to y for x. Then, step 2, interchange your x's and y's. This leaves you with your inverse function. Let's apply this to a situation to find the inverse. Example 4. Find the inverse of the following function. Let's rewrite our equation down here. Again, we're trying to solve for x. So let's go ahead and subtract both sides by 2. Then square both sides, squaring the left-hand side and squaring the right-hand side. What this does is it removes the square root from the right-hand side. Then finally add 4 to both sides, and we get that this is equal to x. The last step, we just need to interchange our x and y's, and what we get is that y is equal to x minus 2 raised to the second plus 4. Let's go ahead and make sure that this is the inverse function. So first, compose f with, let's call this function g. Then this is equal to 2 plus the square root of x minus 2 raised to the second plus 4 minus 4. Canceling out these like terms, we get that this is equal to 2 plus the square root of x minus 2 raised to the second. The square root and raising something to the second power cancel each other out, and we're left with that this is equal to 2 plus x minus 2, which is equal to x. So we found f composed of g. Let's go ahead and find g composed of f. Now, inside these parentheses here, we have a 2 and a negative 2, which cancel each other out. This is then equal to the square root of x minus 4, all raised to the second power, plus 4. The square root and raising something to the second power cancel each other out, and we're left with x minus 4 plus 4, which is equal to x. And what that means is that the function g that we found is equal to f inverse. Let's find another inverse function. Example 5. Again, we're assuming that the function we're given is one-to-one. And we're looking for the inverse of the following function. We want to go ahead and solve this again for the x values. So we want to isolate the x on one side. Multiply both sides of the function by x plus 2. Let me first copy the function down. Now I'm going to multiply both sides by this x plus 2 here. So multiplying the left-hand side by x plus 2 and multiplying the right by x plus 2. This gives us x plus 2 times y is equal to x. Let's go ahead and distribute this y across. And the left-hand side becomes an xy plus 2y is equal to x. Subtract xy from both sides, and we get 2y is equal to x minus xy. We can pull an x out from each of these terms here. And now go ahead and divide both sides by 1 minus y. the very last step, all we need to do is interchange our x's with y's. And what we're going to get is y is equal to 2x divided by 1 minus x, where we have that y is equal to our f inverse. In this last problem of the section, let's go ahead and find a domain on which the given function is 1 to 1, and then find the inverse. Example 6. Suppose we're given the function f of x is equal to x squared minus 6. Find a interval where f of x is 1 to 1. Then find the inverse. Let's go ahead and just sketch a picture of the graph real fast. Our original graph is the graph of y is equal to x squared, which is just a parabola that opens up. But we know if we're looking at y is equal to x squared minus 6, we're going to be shifting our graph down by 6 units. By the horizontal line test, we know that our graph is not 1 to 1 if we include all positive numbers and all negative numbers. So let's go ahead and restrict our graph to only the positive side. So we only want all the y values that come from the positive x values over here. So if we let x be strictly greater than 0, then the graph of our function looks like half of a parabola. Then our function y is equal to x squared minus 6 is now a 1 to 1 function on this interval here. Another interval where this would be a 1 to 1 function would be on the interval from 0 to negative infinity. But let's go ahead and use this one. So we want to find the inverse of y is equal to x squared minus 6. So solve for x, subtract both sides by 6. This is equal to x squared. Then take the square root of both sides. The right-hand side just becomes x. So x is equal to now a plus or minus square root of y minus 6. And since we're assuming that all our x values are strictly greater than 0, then we only want the positive square root. What we get then is x is equal to the square root of y minus 6, which means that f inverse is going to be equal to y, which is equal to the square root of x minus 6. And that's our solution.